let's say problem of SCC. And first we're gonna build graph. Second we're gonna use time relaxation. Yeah. But first thing first, we're gonna import the thoughts dict from collections. And you know what? First we'll start from 0. Okay, let's just write down this graph, which is 0 has 1 2, 1 has 0 2 and 3, 2 has 0 and 1, and 3 has 1. Okay, and start from 0, and we'll go to 1. We'll go to 1, and 1 has 2, and 1 has 1's neighbor is 0 2 3, but 0 we cannot visit. Let's say maybe it should be added to visit, but let's just not come to the conclusion so fast. So let's say we're going to 2, and then we go to 2 has 0 and 1. 1 is its parent. It is where the path goes to our place too. But 1 is, because 0 is 0 and this is 1. And 2 is 2 at this time. But you know what? Because 2 has a neighbor but not parent of 0, so it should be updated. And we're gonna back to 1. 1's parent is 0, but its neighbor is 2, so it updated to 0. And then it will go to 3. Actually, I should do this and do this. Yeah, it goes to 3. 3 has a time of 2. But 3 has no, has no neighbors, but just its parents. So we come to this conclusion that the result should be 1 3. Okay, let's just get started with coding. We need results, graph, and time map, which are this and the default dict of lists and the regular dict. Okay, now let's build graph for starts and in connections. Graph starts append and graph and append starts. Okay, now our graph should be the same like this, but maybe not in this order because it's map. It's a dict, and we're gonna use dfvis to do the job. But first it's -1 because 0 has no parent. The parent should not be in this range, so let's just say it can be n+1, and it also can be -1 because it's easy to write. And time, and let's say set, and last return results. So let's define our DFS. It has parent, current node, time, and processed. So whenever because we have to do the recursion, so I first processed at our current node, and we save our current time here, call this, and let's just visit our neighbors. Neighbors are in GraphCur, and if only if the parent equals to the neighbor, we need to continue. Otherwise we can always do the job, but if it's visited, we should not go to the next round of recursion, because we want to prevent the infinite recursion. So if neighbor not in process, we're gonna use DFS, but its parent now is current, and its current node, the next current node is neighbor. Time plus 1, and the process passed in. So let's do time relaxation now. Time relaxation. So which is okay, time map. Cur is min of time map. Cur the current time of the current node. You know what? I can just write this. Yeah. And time map of its neighbor. If time map occurs is greater than time map cur. Oh my, it can. Okay, because time map of the current node can be can do relaxation for several times, so we better you still get this, because it might first down and first go down to a lower time than the current time, and then go even lower. So we need to this relaxation, of course. So if time at map of current node, which is no, not current, it should be neighbor, because we gonna do this when we meet 1, and when we meet 1, the 3 is our critical connection, which is 1's neighbor. So rest append our neighbor and our current. So a key point of this problems of this solution, let's say it's this: even if the neighbor is processed, it can still be used to do time relaxation, except for parent. Yeah. So let's run all test codes. Okay, all passed. Okay, cool. Thank you very much, guys. Have a nice day and see you in next video. Thank you.